University of Iowa graduate student Megan Mathews is getting her degree in informatics, which is an interdisciplinary program offered on campus. She received her undergraduate degrees from the University of Iowa as well, combining her passions and receiving degrees in intermediate art and psychology. With a combined interest in both science and art, she found the perfect role on campus working on the bicycling simulator research project.
This is an excellent mix of science art. From the science side, I'm learning about how to do programming and also how to build models in 3D environments. And from an artist side, I get to use my aesthetic abilities and my background and color and really get to build interesting looking, engaging objects.
The bicycling simulator uses virtual environment technology to study how children and adults cross roads with traffic. The bicycle sits in the middle of 3 large screens and is equipped to feed real-time information to a computer network, which creates an interactive virtual environment.
We can have kids or adults ride the bike up to intersections where there's cross traffic, and their job is to look at the traffic and figure out when they think they can cross without getting hit by a car.
Megan uses her interdisciplinary background and love of the arts and science to examine research, write code, and create virtual characters.
As a graduate student, I've really been involved specifically with building an avatar that responds in a naturalistic way to real human movements. I love this research because every day is different. Some days I'll be sitting behind a computer and programming dynamics code. The next day I'll be working on sketches for a child character and bringing that to life.
The simulator itself is also an interdisciplinary project. The research is conducted in tandem between the departments of psychology and computer science.
You can't go out in the real world and ask kids or adults to cross roads for you to see how well that they do. We need to be able to do this in a safe way, and the virtual environment allows us to do that without putting kids at risk when they're doing the task. It allows us to have complete control over the entire situation.
Creating a simulator isn't an easy task. There are only a few bicycle simulators worldwide, and far fewer that use them for research. And that's where the Department of Computer Science steps in.
We designed the software and put together the hardware that create the simulation environment. Part of what has to be done is to design the environment, and so that's to specify where the roads are and what textures are on the road, where the houses are and where the cars are. The dynamic things have to be placed on the roadway during the simulation, and so that has to be controlled with software. So we write software that writes behaviors for little car driver behaviors that control the motions of the vehicles.
Children delay in initiating their movement more than the adults do, which results in less room between the child and the approaching car.
We're interested both in the decisions and in the crossing actions. We can look at the decisions in terms of the size of the gaps that kids choose to cross, and then we can also look at how they actually act on those decisions. So how do they actually cross the roads? And one of the things we found is that our 10 and 12-year-olds and our college-age students, they basically choose the same size gaps to cross. But the big difference between kids and adults is how they act on those decisions.
And this kind of research is important to all parents, including Jodie, who has 2 kids of her own.
Any parent can relate to this because unintentional injuries or accidents are the leading cause of death and disability in children between 1 and actually up to age 34. Anybody who's a parent is very concerned about children's safety, and my interest was trying to figure out what is it about kids' immature cognitive abilities or perceptual motor abilities that really puts them at risk.
We just finished building a second simulator and are working on connecting them together. So 2 riders will ride, each in their own simulator, down a virtual roadway, but they'll see each other graphically represented together.
A second simulator will be able to provide greater insight on child bicycle safety, including influence from other kids. And keeping children safe is what motivates this team.
It's amazing to be able to have a job where I get to my office every day and I get to think about what interesting research questions that I want to answer.
The technology is exciting in and of itself, but to be able to take that technology and put it to use to solve these kinds of problems for children's safety, but also more broadly to be able to study vehicle safety in general.
Working in this lab, it has given me the kind of foundation experience for, taking interesting intersections like virtual environments and gaming and bringing them into an applied setting. And, it's an interesting way to sort of build a career.